I'm going to write down a piece of code for this linear search algorithm. Now first of all, I'm going to take one example and we will see the working principle of this linear search. See, this is also known as sequential search. Fine. Now suppose this is our data, this is our array having how many elements? N is equal to 8 elements, and index is from 0 to 7, right? Now suppose you want to search a data and value of this data or key, or you can take any variable. I am going to take here data, a variable data. Suppose you want to search 42. You want to search is 42 present in this array or not. Now here two cases are there. One is element is present in the list and second is not present, right? If element is present, now in that case you want to print the location of that element, where that element is present in this array. Maybe you can say at which index, or you can say at which position this element is present. So see here the index for this 42 is 5, right? And position is what? 6th position. 1, 2, 3, 4, 5, 6, 6th position, right? So either you can print index or you can print location. Now see, if element is not present, then you want that your program should print element not found. So now let us discuss the working of this linear search. In this case, we are going to start our search from starting of the array, from the 0th index, fine, and we are going to access each element of the array one by one and see whether this is the desired data you want. If yes, then you are going to return that location. If no, then you'll move to next element, then to the next element, then next and like this. Now see, for 42, first of all we will check here from this, we are going to start from the starting of the array. 15, is this element same you want? No, then move to next element. This is not 42, next element, this is also not 42, this is also not 42, next and next. Now here you find what? 42. Now where you are going to stop your search? Two cases are there. First stopping condition is you found the element, like 42, you have found the 42 here. Now you are going to stop your search algorithm here, and now this algorithm will return the index 5, that 42 is present at index 5. Or second case is if data is not present in the array. Let us suppose you want to search 41. Now here is not 41, here not 41, not 41. Now next is what? You are going to stop here, na? Because next we don't have any element. So now second stopping condition is you have reached to the end of the array, fine, and the data is not present here. So now you have to stop. Two stopping conditions are there. Either you find the data or you reached till end of the array. Now how to write down the code for this? See, you can write down the iterative method using for loop, or you can write down a function of linear search and you can call that function in your main function. Either method you can follow, fine. I am going to follow here the iterative approach. I am going to write the for loop. See, we are going to start a loop from this index, 0th index, and the loop will go till end, right? Now see, here we have one for loop. We will take one variable I is equal to starting from 0 and I less than n and I plus, because here n is 8, so it should go till 7, less than 8, that is from 0 to 7, fine. Now next what you will do? You have to find what? 42, okay. Now you will check if name of array is A, if array of I value would be, first of all I value would be 0, then I plus, then 1, then 2, like this we are going to search. Now we are going to access each element of the array one by one and we are going to search, and we are going to compare is this data we want to search, right? So if array of I is equal to data, then what you will do? You will return the location of that data. You will print. So here you will printf you can write here element found at index %d, and you want to print the index, so here you will print what? I, right? At index. So 42 would present at index 5th. If you want to print the position, you can say element found at position I plus 1, means at which position? 6th position. Now suppose we are going to write this thing only. This is closing of this if, this is closing of this for. Now see, let us trace out this code for this 42. Fine. So I value is, at starting I value is 0. I is less than 8, yes. We will enter into this loop. If a of 0 is 15, 15 is equal to data is 42, no. So control will not go within this if statement. Now after if the control will go to I plus plus. Now I is equal to 1. A of 1 is equal to data, no. Now I is equal to 2. A of 2 is equal to data, no. I is equal to 3. A of 3 is equal to this data, no. I is equal to 4. A of 4 is equal to data, no. A of 5. Now see, A of 5 is 42, 42 equal to data is 42, yes. Now control will go within this loop. Now what control will print? Element found at index 5. Fine. Now see, the problem is here. Now see, again after this if control will go to I plus plus. Now I is equal to 6 and 6 is less than 8, right? Now again we are going to check if A of 6 is equal to data, right? But that is not true. Again I plus plus I is equal to 7. Again 7, A of 7 equal to data, no, we are not going to enter into this loop. Now again is equal to 8. Now 8 less than 8, no. Now control will go out from this for loop. Now here the drawback is what? For this code drawback is what? We have found the element at index 5th, but still this code is searching for 6th location also and for 7th index also. Now what is the point to search after finding the data, right? We have found the data, na? Now at 5th index only we have found 42. Now what should be done? This algorithm or this code should have stopped at here only, but this is not stopping. Now you have to add one more condition here, right? You have to write what? Break. After this printf you will write break, and after you will close this if statement. Now see, this break means what? As soon as control will go to this break statement, then what? The control will go out from the loop in which break statement is written. Now break statement is written in which loop? Which for loop? Here. So we found the data at index 5, right? Again control will go to here only, break. Break means the control will go out from this loop, here only. Now if you write this break, then we will not search for this location and for this location. This is the stopping condition now. So now next case is if element is not present in the list, in the array, then what you will do? Then you will print what? Element not found, right? Now where to write that condition? How to write that condition? See, if element is not present, if suppose we are going to search data is equal to 41 and that 41 is not present. Now finally when I is equal to 7, 7 is less than 8, data is 41, A of 7, is this 41? No. Now again I plus plus I is equal to 8 and 8 is less than 8? No. Now control will go out from this loop, whatever you will write here. Fine. It means if I value has been reached to 8, here 8 is what? Number of element. It means if I value becomes same as this n value, number of elements, in that case data is not present, you can say, right? So what you will write? Here you will write if I value equal to n. In that case you can write here printf element not found. And if you don't write this condition, if you don't write this one second method to print this statement is element not found is, see, you can take one variable here at the starting, you can take either found or flag, it's up to you. I am taking found. A variable found is equal to 0 in the program at starting. And if you find the element, in that case you will do what? You will convert this found value to 1, means found is equal to true. Now we have found the element, right? So before this break here you will write what? Found is equal to 1, right? And here after this 4, if you don't write this condition, then second case is, this is case 1, you can write this also. This is case 2 and you can write this also. Here you can write if found is equal to 0, it means you can print f here data not found. If found is equal to 0, it means control has not entered into this if condition here, means this condition never becomes true. So that is why after the for loop also still found is equal to 0, it means found is equal to false, element is not present. So you can write element, you can say element not present. So you can write this also, you can write this also. If you write this case, then you no need to declare this found variable. See, this is not the complete program, so you have to write some another statements also. This is just the main logic, not the complete program. So now what is time complexity? First of all, we are going to check in best case. Best case is what? Suppose this is our array and you want to find out data is equal to 15. Fine. In linear search, we are going to start from the initial point of the array, from the 0th index. Find out, check 15. First, at first index, at 0th index, we have value 15. 15 is equal to this data. Yes, it means in one comparison only you have got the data. So in the best case, the time complexity would be order of 1 only. What about worst case? Worst case means, suppose you want to find out the data 17 here. How many comparisons you have to do? First of all 15, then 5, then with 20, then 35, 2, 42, 67 and then 17, and here you got the data. Means n comparisons, 8 comparisons, right? So that is why here the time complexity in worst case is order of n, the number of elements, total number of elements, n. If you find out the time complexity, you just do what? Check out where is the loop in this program. Here we have loop, and find out the statements written in this loop, how many times they are being executed. That is the time complexity. Fine. So see, these statements printf and break are only 1 and 1 time, so this is constant. Only this if statement, this would be executed for how many times? Maximum. This would repeat for maximum how many times? Till n, right? So in worst case, time complexity would be n. Now what about average case? How to find out average? See, average means sum of all the cases divided by number of cases, right? Sum of all the cases. How many cases can be there? See, one case is the data is present in the 0th index only. In that case, how many time complexities or how many comparisons are there? 1 only. Plus, if data is present at here only, in that case, how many comparisons are there? 2 only. Plus, third case is data is present here only. Now, in that case, how many comparisons? 1, 2 and 3. Like that till n comparisons. How many cases? Sum of all the cases, right? Divided by number of cases are n, right? And I hope you know the formula of this one, 1 plus 2 plus 3 up to n, that is n into n plus 1 divided by 2, and here we have n. So the time complexity would be order of n plus 1 divided by 2, you can say. So this is all about linear search. In next video I am going to talk about binary search. Fine. So till then, bye bye, take care.